This is part 2 of the series, The Basics of Geometry. In the last part, we ended with a description of the defined terms, and we are going to now begin with our first defined term, which is a line segment. A line segment is a term made up of the undefined term line, and we're going to be talking about a portion of a line that is the set of all points between 2 points called endpoints. Let's look over here at this diagram, and this is a representation of a plane that we've seen in the last section. And here we have a line RS in the plane. If we take a look at the set of all points between R and S, that constitutes a line segment. That's a portion of the line that starts at R and ends at S. Or we could say it starts at S and ends at R. And line segments are named with 2 points and a straight bar with no arrowheads across the top. Recall that line RS was named with the letters R and S and a bar with 2 arrowheads across the top. In a line segment, we leave off the arrowheads to indicate that it's starting at R and ending at S. The arrowheads indicating that it goes on forever. So for a line, we had line RS, and these arrowheads indicate that it went on forever this way and this way. Segment RS is indicating that it starts here and ends here. So a line segment is just a portion of a line. We could have also said segment SR here. Looking at one of the other lines, we have this line here. We could say that we have segment TU, we have segment UT, TV, and segment VT, as well as segment VU and segment UV. All those would be valid line segments. Segment UT and TU would be the exact same segment. Segment TV and VT would be the exact same segment. Now, in this plane, we don't have a segment described by S and T. We could draw one in this picture, but at this particular point, there is no segment ST, so we would not list that as one of the segments that's in here. Now these symbols refer to the name of the line segment, but line segments also have attributes. Remember that lines have no width and no thickness, but they do have length. Lines have infinite length. Therefore, line segments have a finite length. That is, they have a length that can be actually measured. And so we're going to need to be able to describe the length of a line segment. So that's what we're going to look at next. Now I cannot stress this enough, that the way to represent the length of a line segment is just the letters R and S, the 2 endpoints that describe the segment. So here we have the segment name itself, RS with the bar over the top, and the length of the line segment is simply RS. So if you were given these 2 letters, R and S, and you were asked, what does that say in English? Your result should be length of segment RS. This is one of the capital things that people make mistakes on as they move through their early geometry career. That 2 letters with nothing over the top indicates the length of a line segment. You're going to see this all the way through the course, so it's very important that you make this distinction. So length of is 2 letters with no bar. Likewise, if I wanted the length of this line segment from T to U, it would be just the letters TU. That means length of segment TU. Same thing for TV. TV would be the length of segment TV. All right, let's move on to the next topic. The next defined term in our list is called a ray. Think of light rays, rays from the sun. They start at one point and they go out infinitely in one direction, a ray. And that's what a ray is. It has one endpoint and extends infinitely through a second point. You would name a ray by listing the 2 points that are part of a line. Just like a line segment, a ray is part of a line. So in this line, let's go back to line RS. Again, we recap. We say that we have line RS. Now if I want to label this ray RS, we would have the 2 letters signifying the ray and one arrowhead. There is, on the left end, there is no arrowhead. On the right end, there is an arrowhead. This is always going to be the case. The left character, the left letter, signifies the character of the endpoint of the ray. So in this picture, what we'll be talking about is all the points starting at R and moving through S infinitely in that direction. The difference being that none of the points on this side of R would be included in that ray. So again, RS, ray RS, starts here and goes that way forever. So that would be RS. Now if I wanted to go in the opposite direction and say ray SR, it would be this. That is, S is our endpoint, and we extend infinitely through R. Start at S, extend infinitely through R. The difference between these two is that this ray, SR, does not contain any of the points to the right and above point S, whereas ray RS doesn't contain any of these points. So there's a specific distinction between these 2 rays. They are not the same. So don't make that mistake. This is line RS. It includes all the points going that way infinitely and that way infinitely. This includes all the points from R through S infinitely in that direction. This includes all the points from this point through R in that direction. Now if you note this line, line UV or line TU, we have a different situation here. In this case, we can describe several different rays. More specifically, we can define rays using point T as their endpoint. We have ray TU and ray TV. Notice how both rays, TU and TV, have the same endpoint, point T. So we have ray TU and ray TV. The distinction being that they go in opposite directions. So 2 rays with a common endpoint extending infinitely in opposite directions is known as opposite rays. So those 2 are opposite rays. So you want to make note of the fact that point T is the first letter in each ray. So TU and TV, indicating that that is the common endpoint. Remembering that the left letter is always the endpoint. Notice the left letter is coincident with no arrowhead, meaning the ray starts there and goes infinitely through the second letter. The ray starts at T and goes infinitely through V, through that second letter. Now up to this point, we've talked about the individual objects, that is points, lines, planes, segments, rays, opposite rays. But what happens when these guys interact with each other? We looked at one very, very briefly when we talked about line UV passing through a plane, but we need to look at the interactions of these things in greater detail. So that's what we're going to be doing now, is talking about intersections of these objects. When we talk about the intersection of 2 objects, we're talking about the set of all points that 2 or more objects have in common. And the first thing we want to look at is the intersection of two lines. So here we have two lines, line L and line M. I need to note here that you can name lines with something other than 2 points on the same line, 2 collinear points. If the diagram has an italicized lowercase letter associated with that line, you can always use the word line preceding the letter for that line. So this line would be line M. This line would be line L. In this particular picture, since we only have 1 point, we couldn't use collinear points to name either of these lines. So looking at the intersection of line M and line L, here we have an object that has no thickness and no width intersecting another object that has no thickness and no width. That would create an object that has no length, no thickness, and no width, which is the description that we give of a point. And so the intersection of two lines is going to be a point. If you look here, we have two planes, plane Q, and this vertical plane, plane R. They intersect at a line. If you were to look around you in the room that you're sitting in and try to see if you can find a representation of a line, one of the things you might notice is that the walls in your room meet at something that looks like a line. So if you take this as one part of the wall and this is the other part going in opposite directions, say the wall and the floor, that intersection of the wall and the floor would be a line. And if you look around you, lines can be represented by a lot of different things, but the intersection of two planes is always going to be a line. Now, since the intersection of two lines is a point, then it should be clear that the intersection of a ray in a line, a segment in a line, two segments, two rays, those would all intersect at a point, since all of those defined terms are based on the undefined term line. Now that we have a basic working vocabulary of undefined and defined terms and some of their interactions, we need a method to start putting these things together to do some useful work. And with any system, we need rules. There's always going to be rules that govern the behavior of a system. Now, geometry is known as an axiomatic system. That is, a system based on axioms. In English, an axiom is simply a rule that's taken as true and doesn't require any proof. In geometry, the same term is called a postulate. A postulate is a rule that is accepted as true without proof. And as I said before, a geometric postulate is also known as an axiom in English. One of the very first ideas that Euclid wrote down when he wrote his book, The Elements, is a postulate. And it was known as the two-point postulate, which says that through any 2 points, there exists exactly one line. So here's the idea. If you have 2 points in a plane, then you can draw exactly one line through those 2 points. And the reason that you can only draw one line through those 2 points is because these points have no dimension at all. They look like they have width here, but they really don't. And since lines have no thickness, it is not possible to draw another line over the top of this one so that you have 2 lines going through that point. Now, it might be possible to do something like the following. You could try to fake things out and do something like this. And you could say, well, there you go. There's a curved line. Well, curved line is a misnomer. There's no such thing as a curved line. A line is a straight object. A curve is simply a curve. To say a curved line is an oxymoron. You can't have both of those words in the same sentence. So this is not valid. You really can't do this. So through any 2 points, there exists exactly one line. Now we're going to go through our first postulate that we're going to use as a working idea in the next video. So I will talk to you then.